So all I know is this. That's e to the x plus c. Well, I don't have e to the x, so what would you like u to be? Times what? I suppose you could do it that way. Let me think. You could, but and yeah, you could probably do it that way, but why don't we just let u equal 2x? Because then, isn't that then e to the u? Those are dummy variables. Care what you call them, it doesn't matter. And if u is 2x, then what's du? 2 times dx. You have to have the dx there. Because that's what you're doing. When you substitute, when I'm looking over here to substitute, I've got this taken care of. That's u. Now I've got to figure out what dx is. I don't want 2dx. I want dx. So what are we going to do? Divide by 2. So I get 1/2 and du. That makes sense? No? Gotta ask. I am accounting for everything in this integral. I have to replace dx with a du, but it's not a direct replacement. I've got 2 of them. I only want 1. So I have to take half of it. And then on the exam, often they do this. They say, just set up the integral. So for A, they might have written down the integral from 0 to 2, e to the u du. And then the next one might be 1/2 the integral 0 to 2, e to the u du. Both of those are wrong. Because what are the 0 and 2? Those are x's, right? This is x. So if x is 0, then what is u? U is equal to 0. That one's okay. But when x is equal to 2, u is equal to 4. So then the next choice would probably be the integral from 0 to 4 of e to the u du. Be careful. And then part in D, what would be the correct one? Because they want to get you on this. These are called distractors. I want to make sure you're really doing the problem. It's so easy to look at the first one and say, oh, that's the answer. Or you might have saw, well, I have to have 1/2. That's the answer. And you have, the multiple choice are online, but if you were to look at the answers of the multiple choice, I should have scanned the results, how many people got them right. Kind of interested to see a problem. You go, I got that right, and only 20% of the people got it right. It's cool. Okay, so they may just ask for this, but now let's go ahead and substitute in. First off, this little green, let's not green yet. This little symbol, this little s, with the du means find the antiderivative of that. It's used up, it's gone when I anti-differentiate that. So what is it? E to the u. Evaluated at 0 and 4. Question, guys? And then you just substitute it in. So it's e to the 4th minus 1/2 e to the 0. What's e to the 0? What's e to the 0? 1. Okay? My guess is if you struggled with this, you probably didn't do that much of the homework. The homework is essential. You can't just watch in class and say, I've got it. It doesn't work that way. Now, if it's too bright, we may have to close those. I don't know, you're in the back. What's done? And let's look at the schedule right now while I'm thinking about it. So today we're going to do 6.4, day 1. And we have a little quiz. Tomorrow, we're going to do 6.4, day 2, which will get us into exponential growth and decay, which is really, really important. And then Wednesday, we're going to have a quiz on integrals. We're going to involve u substitutions, both definite and indefinite. Do you remember what that is? A definite integral is going to look like the integral from A to B. An indefinite is just an integral. Okay? And Wednesday's a really special day. 2 reasons. It's the 29th of February. It's leap day. Seniors, yes. Yes, and seniors, you're the only class that's being affected. Seniors only are going to be at, there's going to be a speaker in the large odd. Yeah, it's prom. Okay, seniors, I hate to do this to you, but you're going to have to watch the video for tomorrow. Sorry. Seniors. Okay. And the other special thing about Wednesday is starting tomorrow afternoon, we're supposed to get 12 to 15 inches of snow.
Yeah, possibly snow day, maybe.
There's always a possibility. We can hope. Cautiously hopeful. Now, that would be really nice. Now it's coming in tomorrow night. So Thursday, well, Thursday's not a tough day. Thursday is review. So what do you think is happening Monday? Yeah. We have no school Friday. Because it just lined up that way. If we get a snow day, it'll get pushed back because we have the time to do it. BC does not have the time to do it. If we have a snow day, or even if we have a late start because everything gets totally messed up, then it'll be Monday and it'll be Tuesday, Wednesday. But we haven't had 15 inches of snow either. We did actually last year, but it was never before a school day.
Always on a Friday night.
That's just to keep you guys out of trouble. Okay, that's the plan. There are 3 sections. Guys, we're right on the calendar. Calendar we gave you is still right. And we have 3 sections in Chapter 7. We will give you practice AP problems. On the assignment, I'm going to get on my iPad here real quick. The assignment we're going to change today, and we're going to, tomorrow you're going to get some free response questions with differential equations. Okay, so, page 357. This is the assignment. Quick review 1 through 10. Page 357. 1 through 13 odd. 21 and 25. Okay, that would be right. So we're changing the assignment on the assignment sheet. Use substitutions. That's what we did. We should not necessarily need them. We might with our differential equations. So let's get into the lesson. And right there, what does it mean to solve an equation? That's how you solve, but what does it mean to solve? If I tell you x plus 3 equals 7, and I solve it, I'm going to tell you x equals 2. What do you mean it's not right? How do you know? What's it? It's got to strike it out of our vocabulary. Yeah. Did this make this statement true? No. So what do you mean to solve an equation? You want to find the number. These are numbers now that make the sentence true. If you know that, then things get a lot easier. Things get to be a lot easier. So, a solution, those are the numbers that make the sentence true. It could be more than one number. So can I just do this by inspection? Couldn't I just do guess and check? Sure, why not? When I first started teaching, I said, you can't do that. Well, I was wrong. Yes, you can. But the problem is, if things are complicated, I'd better learn some techniques to actually find out what the solution is. I might not be able to just look at it. If the decimal ends up being E, for instance, I'm in trouble. I'm not going to guess that number. Okay, now I'm going to put a little star here by this differential equation because this is a test question. Easy 2 points. 75% of you will get it right.
Yes.
But it should be how many?
100.
It should be 100. Okay, what is a differential equation? It's an equation involving, somebody said the word, derivatives. And when you're solving a differential equation, it's kind of nice to know what it is you're solving. But when I solve this, I'm not going to get a number. What am I going to get? I'm going to get a function whose solution is a function. So when we solve a differential equation, what does it mean to solve it? We want to find that function. I don't think it's in green. To find not a number, but a function that makes the sentence true. And we did this in 6.1. Now when I say you're going to find a function, then that means you have to have y equals. You can't leave it y squared equals, or the sign of y equals. It has to be y equals. And that's for the final point on these problems. I love the differential equations because they're all solved exactly the same way. Always the same way. Now it's getting sunnier. Can you still see the board? So here's a problem, and we're going to have to write an equation. In fact, I've seen problems very similar to this on the exam. Sorry. They'll give you a word problem. You're going to have to write the differential equation. It's in the multiple choice section. Okay, Adam?
Yep.
And it says, consider the function whose slope. How do you write slope? dy dx. That's what slope is. Is, what do I put in for is? Equals. It's always the square of the x coordinate. So it's x squared. And we have an initial condition here. So we're going to find the particular solution. And often, I have not seen them just find the general solution. I've always seen them find the particular solution. Okay, do you remember the steps? First thing, do what?
Find the answer.
Separate. I can't. Got to separate the variables. So you should be doing this with me, not watching. Next year, when you go off to college, seniors, you'll miss me. Because the professors are just going to write really fast, talk really fast, and be done. And you're going to go, what happened there? No. Okay, so you may think I go fast, wait till college. So we have to separate the variables. And if you don't do that, you are done. This is a 5-point question. Easiest 5 points on the exam because you always separate the variables. So I'm going to multiply by dx. And then you check, do I have only x's together and only y's together? I don't have any y's over here, do I? You can't. You have to have only x's on one side, y's on the other side. And the only ones you can undo is this multiply and dividing. Okay, so now what do we do? Integrate it. Each step I write down is a point. Integrate. Now sometimes this is 2 points. If these were difficult antiderivatives, it would be worth 2 points, one for each side. But lately I haven't seen them doing that. So what's the antiderivative of 1 dy? That's just y. Yes, there's a c there, but what I'm going to do is put all my constants over there. I don't care what they are individually. It's not important. And then this is what? X third divided by 3. And what do you have to do next? Add the c. You don't do it now, you get no more points. So you would have 2 points if you don't add the c right now. And some of you are going to get in the middle of a problem and think, oh, I forgot to put c, and then you're just going to throw it in later. You've got to put it in right after integrate. And then we're going to find the particular solution. I know it goes to 1, 4/3. So we're going to find c. Now you get a point for just making the effort. So if I substitute these in the wrong place, oh well. Let's look at my point. You just won't get the final answer point, that's all. Okay, so in place of y, I'm going to put what? 4/3. In place of x, I'm going to put in 1. Can you tell me what c is? Can you just do that in your head? 4/3 minus 1/3 is 3/3 or 1. We're not done until you actually substitute it in there. Find c, and the fifth point is find y equals. It's 1 point. If you can't do that, don't worry about it. This was an easy one because it was already set up for us. Next one will not be easy. So y is equal to x cubed over 3, and it won't be easy on the exam, plus 1. And so what we're going to give you is some practice problems from previous exams. Okay? Is that okay? Is it hard? Can you remember to do all that? No. Oh, this is not the right order. Okay, let's do this one. And I'm not going to find the general solution. I find that it just confuses you, so we're not going to do it. I've never seen it on the exam where they just ask for the general solution. Watch. Every time I say that, that always ends up on the exam. First year teaching this, I said, oh, they won't ask you the trapezoidal rule, and yes, they did. And I didn't get to it. And that's my first year. Okay, so I want to solve this differential equation. It wasn't even an AP class. I made it an AP class. Okay, so dy dx is equal to x over y. So how can I separate that? Yeah, let's cross multiply. So you should do it with me. Watching is going to get you anywhere. I watch a lot of basketball. I'm pretty bad at it. It doesn't do the trick. I got to get out there and do it. So it's y times dy. Make sure you notice the operations. It's x times dx. Are they separated?
Yeah.
Okay. And now what are we going to do? Integrate. So what's the antiderivative of y? Y squared over 2. This was actually hard to get to the final right answer. Equals x squared over 2 plus c. If I don't put the c in right now, I am done. I've got 2 points, I'm done. Some of you may say, well, you know what? It's so much easier to solve for y first, and then we'll put the c in. That's true, it is, but it's wrong. That's the only problem with it. So put the c in now, and put in the point now. Let's find c. And if I put the point in wrong, my answer point will be wrong. That's it. So what am I going to put in for y?
4.
So it's 4 squared over 2 equals 2 squared over 2 plus c. In physics C, are you guys doing these kind of differential equations? No? Okay, so it's 16 halves, which is 8. 4 halves, which is 2, plus c. So c is equal to 6. Okay, what am I going to do now? I got to put c back in there. So I'm going to get y squared over 2 equals x squared over 2 plus 6. And that's not solved for y. You have to solve for y. So do you guys like fractions? I like fractions, but why don't we multiply everything by 2? Because then I'll end up with y squared equals x squared plus 12. I'm still not done. Now what do we do? Adam, what do we do next? Okay. Careful with the its. So I have to square root each side. Can I make that x plus the square root of 12? No. You may not distribute square roots over addition. You can distribute multiplication division over addition, but not square roots. Now, what's the answer to this one? What's the square root of y squared? No, it's not y. It's the absolute value of y. Why am I picky about that? Because some of you think it's plus or minus. It's not plus or minus. Square roots are always positive. But I'm going to get a plus or minus because I'm going to solve this equation. Because what can I put in here for y to make this sentence true? Y can equal the positive square root here, or y could equal the negative square root. Is this a function? I'm talking about functions, but something tells me I'm not sure we know what a function is. Is this a function? No, it's a function. For every input, there's how many outputs? 1. So I put in x equal to 0. How many outputs do I have? I have this one and this one. It's not a function. In particular, it looks like this. If you were to graph everything. Now you're in y equals, so you could graph everything. So that's not a function. Now the positive one will be just this piece right here. It's called a hyperbola. And the negative one will be this one. And what determines whether you take the positive or the negative sign is your initial condition. And that was at 2, 4. So for this function to go through 2, 4, do I want the positive square root or the negative square root? Positive. So this would be y equals the square root of x squared plus 12. And then we gave you another one. We gave you 2, negative 4. And you're going to see this on the exam. It appears on the exam. And then which one do I want now? The first one's not going to give me a negative if I substitute 2 in. I'm going to have to use that one because of that negative sign. And that came from the absolute value. So it's a little tricky. We will practice those problems that are tricky. And what we're going to do tomorrow is we're going to do last year's differential equation. Because I don't want it to happen again. What happened last year to happen again. Okay, let's try another one. That one does not look like fun. Well, you know, I don't like those radicals. How could I write that? X squared, y, not 1/2, 1/3. Adam, please participate. Yeah, you're playing with your phone or something. This is my clock, because my watch broke. Okay, I have to separate that. Right now, it's all stuck together. So what can I do with that 1/3 exponent? Matt? What can I do with that 1/3 exponent? Can I distribute that? You can distribute exponents over multiplication, but not addition. X to the 2/3 times y to the 1/3. Okay, now we have to separate our variables. What should I do first? Julian. This is not easy. This is the guarantee for the 5 on the exam. The differential equation that you're going to see. Very rare have I not seen a differential equation, but I love these because they're so easy to get your points. I still have no points because I haven't separated the variables. So multiplying by dx, dy is equal to x to the 2/3, y to the 1/3, dx. Guess what? It's still not separated. Okay, you guys? Nick, what do I have to do? Zach? Yeah, I don't like this y here. See what the problem is? I have x, y, and x. Can't have that. I can only have x's here and only y's over there, so I'm going to divide by y to the 1/3. Okay? Let's clean that up a little bit. Now remember, the only thing you know how to do is what's on that blue sheet. This does not look like anything on my blue sheet. Well, this does. See, this is going to go. I'm going to get x to the 2/3 dx. Yeah, let's rewrite this as a power with a negative exponent. Now it looks like the power rule. Okay, I know how to do that. Right? What's the antiderivative of y to the negative 1/3? It's y to the what? You're going to add 1. 2/3. So dividing by 2/3 is multiplying by 3/2. Equals, this is going to be x to the what? 4/3. Oops, 5/3. I have to add 3/3. Times what? 3/5 plus c. Now let's find c. I could solve for y, but honestly, you find better when I do this. Or we just, we don't have it. Well, let's find the general solution then. We don't have an initial condition. So what should I do next? I don't want any of the fractions. 1 to 2 and 5 both go into 10. So let's multiply by 10. Some of you might do it quicker, but I don't recommend it. Now, I'm going to leave all those constants in there, but when I'm all done, I can make it a new constant because it's arbitrary anyway. So what do I get here? Okay, 15y to the 2/3 equals, and this is going to give me 2, so it's going to give me 6x to the 5/3 plus 10 times c. Now what do I have to do? Divide by what? 15. Okay, that cancels, so I get y to the 2/3. Can you reduce 6/15? 3 goes into both. 2/5, right? X to the 5/3 plus 10c over 15. I could just call it k if I want. Doesn't matter. How do I get rid of y to the 2/3? Raise it to what power? 3/2. Can I distribute that 3/2? No. And you know what? If it's free response, just leave it anyway. And there it is. So y equals this. 2/5 x to the 5/3 plus, you know what? I'm just going to call that k. Yes? Because it's just a constant. It's any old number, really. Because you don't know what c is. C is 0, it becomes a certain number, but that's it. What's my time? What's my next one? I want to show you something. Oh, that's a fun one to try. Why don't you try that? You're going to have to do some changes. Adam. Do you do that at home too? What? Julie, you going to come up and do this?
I can do it.
You want to try it?
I'll try. If I do it on the board,
First off, I don't like the square root. I hate that.
do that.
You got about 5 minutes.
That's the crucial first step is changing to a. Okay, I'll follow your advice.
That's not equal sign.
Who starts? Distribute the 1/2. Distribute the 1/2, like right. Yeah. So I go x to the 1/2 plus.
Let me see.
What?
Yeah, separate them.
Then can I cross multiply?
Mm-hmm.
Should I cross multiply?
Yes, always.
Oh.
I'm trying to get you to slide.
Why the 1/2 slide?
There we go. You gotta move for a
Oh,
second.
I gotta click that.
There you go.
Okay.
Oh, you're gonna cross multiply. So you're gonna have y to the 1/2 times dy.
Yeah.
Oh, but we don't write it that way.
No, we don't.
No, it's not a negative 1/2. You have to put the y to the 1/2 first.
Oh yeah, that makes sense.
Equals x to the 1/2 times dx.
Then we're gonna integrate it, right?
Well,
No?
yeah,
Never?
yeah.
Am I doing this wrong?
No, it's just so hard to read. Because,
Oh, it's not negative.
no, it's not negative. It was this. X to the 1/2, y to the 1/2. Okay, what's the antiderivative of that? Come on, you guys, we don't have much time.
Yeah, you guys help me out here. If you don't help me out, we might not be able to take this quiz.
So what's the antiderivative of y to the 1/2? Times? No, times 2/3. It's too messy to do it with a complex fraction. Okay, equals. No, that's not a negative 1/2. It's a positive 1/2. Oh, never mind. My mistake. Let's see. Okay, so he's got 3 points.
Substitute that.
0, 9. Okay, guys, put in 0, 9. X is 0, y is 9.
Oh.
So easy to do. If this is free response, it's not worth simplifying that. What? It is. You're not done.
Not done.
Nope. What? You have to put C in. You've got plus C.
Oh gosh.
So put this in over here, but for us, why don't we simplify it? Let's first take the square root of 9.
3 times 27.
No, it's 2 times 27.
But don't you have to take it?
Just 2/3.
But don't I have this stuff on the top?
Yeah, 9, the square root of that is 27. 9 to the 3/2 is 27.
Yeah. Oh, okay.
Don't forget the 2/3.
Yeah.
So what's that give you?
So,
3 into 27 goes how many times? 9 times 2 is 18. Equals C. Okay, he's still not done. You had 2/3. Y to the 3/2. Guys, shh, is 2/3. X to the 3/2 plus 18. How would you solve for y? I want to multiply everything by 2/3. I mean 3/2. Multiply by 3/2. By the reciprocal. And again, I would just leave that if I didn't know what it was. So you get y to the 3/2 equals x to the 3/2, but I'm going to do this. Yep. And so, guys, how do you do this? Julian? What do I do next?
take it to the 2/3.
To the 2/3. The side. I don't want to see anybody distributing.
Go distribute.
You can't distribute. It's wrong. This is a plus sign. You try 3 plus 4 squared, that is not equal to 3 squared plus 4 squared. That's 7 squared. That's 9 plus 16. Certainly not the same. Okay. Time is up. Okay. Let's do this, and at the end, I will bring out my calculator, because the last one you can't separate. You cannot separate that one. Try as you might, you can't do it. So, all I can do is look at a slope field. That's all I can do. So you need to spread apart here so you're not right on top of each other. I know it's hard because it's a big class. Oops. You have to retake it.